Hi, we are Project Scorpio, the flagship initiative of the Off-Road Students Scientific Association. We have been operating for nearly 20 years. Our latest construction is Scorpio Infinity, the 8th installment in our rover series, a well-tested and reliable unit. We are based at the Faculty of Mechanical Engineering at the Wrocław University of Science and Technology in Poland.
My name is Dominik Pawliszewski and I am the team leader of Project Scorpio. I lead our 15-member team, oversee university relations, represent us externally, and manage human relations within the organization. I'm supported by our vice leader, Kinga Adamska, who works closely with me on the organization's day-to-day operations and is responsible for finance and procurement. Our project manager, Krzysztof Piechota, keeps every element of our projects coordinated and ensures smooth cooperation between departments. The management structure also includes 5 department leaders.
My name is Bartłomiej Łuczeńczyk and I'm the leader of the mechanical department. The mechanical department handles the design and construction of our rovers, translating initial concepts into detailed SolidWorks models for production. We use advanced techniques like 3D printing and precision metal machining to tackle engineering challenges.
My name is Jakub Górski and I am the leader of electronic departments. The electronic department is responsible for designing, assembling and integrating the custom PCB system and microcontrollers that power the Scorpio rovers. Our team specializes in programming STM32 units in C++ to ensure seamless communication and reliability across all electronics subsystems.
My name is Aleksandra Korytkowska and I am the leader of the Science Department. The Science Department applies expertise in geology, chemistry, and engineering to solve complex scientific challenges and develop practical rover instruments. We focus on continuous research and active participation in international conferences and industry competitions.
My name is Igor Zaworski and I am the leader of the software department. The software department develops the core code and network infrastructure using C++, Python, and the ROS framework. Our work spans from managing networks and control applications to implementing autonomous navigation and AI-driven solutions.
My name is Krystyna Fluder. I'm the leader of the marketing department. The marketing department manages public relations and sponsored outreach to secure the resources necessary for our operations. Our team also oversees content creation, website development, and the overall growth of the project's public image.
We relentlessly refine our designs and push the boundaries of our technical expertise. Through rigorous training and simulation, we constantly elevate our team's operational capabilities and readiness. We are dedicated to strengthening our presence within the robotics and space sectors by actively participating in industry events, trade shows, and conferences. Having competed in previous editions of the European Rover Challenge, we are eager to return and validate our latest engineering solutions in this prestigious international arena. For us, the European Rover Challenge is the ultimate environment to test our rover's performance against the highest standards and to continue our legacy of innovation. Scorpio Infinity utilizes a 4-wheel rocker-inspired suspension, ensuring exceptional stability and pitch balance on uneven terrain. This configuration allows the rover to overcome 30 cm obstacles and climb slopes exceeding 30 degrees, all within a compact 1.2 meter footprint. The system is driven by BLDC motors with multi-stage planetary gearboxes and features 3D printed TPU tires with a gyroid infill for optimal ground pressure. For critical safety, the chassis is equipped with a high visibility emergency stop button, allowing for an immediate and total power cutoff to all systems. The electronic brain consists of an NVIDIA Jetson AGX Orin for primary processing, supported by a Raspberry Pi for redundancy. The entire system is powered by an 18,000 mAh lithium polymer battery array, providing over 3 hours of continuous operation. CAN bus redundancy is ensured through 2 separate buses, one dedicated to the rover and one for the robotic arm, alongside high-speed Ethernet for vision systems. We utilize a modular architecture with custom-designed CAN boards and detachable hats, allowing for rapid hardware upgrades and field maintenance. Our software stack is based on the ROS2 framework, which allows us to easily develop advanced teleoperation and autonomy algorithms in-house, while utilizing a rich library of thoroughly tested, industry-grade packages such as the ROS2 MoveIt package for Manipulator inverse kinematics. The rover's vision system comprises 10 cameras and a LiDAR sensor, eliminating blind spots and providing operators with a comprehensive field of view. LiDAR, in combination with our in-house developed autonomous stack, enables stable and predictable autonomous traversal by integrating real-time obstacle detection with advanced movement algorithms. To ensure seamless remote operation, we developed a custom GStreamer and WebRTC-based video pipeline, allowing for real-time adjustments of resolution and frame rate to maintain low latency control even in challenging network conditions. Scorpio Infinity utilizes a dual-band Wi-Fi communication system, featuring Ubiquiti Rocket M2 and M5 units paired with omnidirectional antennas to ensure stable, high-speed connectivity across both 2.4 GHz and 5 GHz bands. This modular, interference-resistant setup maintains reliable links at distances up to 400 meters, meeting all operational requirements for the mission. The Scorpio drone is a modular aerial platform built on the Taro Ironman 650 frame, engineered specifically for field reliability and rapid maintenance. Its structural integrity is derived from a central frame featuring detachable carbon fiber arms and aluminium reinforcement plates, providing an optimal strength-to-weight ratio while allowing for the quick replacement of components in high-pressure competition environments. Flight stability is maintained by a 4-motor BLDC propulsion system in an X configuration, ensuring predictable handling and mechanical simplicity. To enhance flight dynamics, the battery is underslung to lower the center of gravity, while fixed landing gear provides sufficient clearance for underslung payloads. The rover is equipped with a 6-degree of freedom manipulator constructed from carbon fiber and 7075 aluminium, achieving an impressive 5 kg lift capacity. By utilizing harmonic, planetary and cycloidal drives paired with frameless BLDC motors, the system minimizes backlash and ensures high precision across its 1.2 meter reach. Integrated slip rings allow for continuous rotation, while advanced inverse kinematics and space mouse support enable fluid and intuitive control during complex competition tasks. To meet the specific requirements of the probing and sampling tasks, the gripper utilizes additional interchangeable, flexible TPU fingers for delicate interactions and specialized spoon-shaped adapters designed for efficient surface sample and stone retrieval. We have also implemented a dual-chamber module equipped with load sensors to verify that we have met the relevant requirements. Furthermore, for specialized analysis, we utilize a dedicated end effector featuring an integrated pH meter, a peristaltic pump and a 100 ml collection vessel for precise liquid or soil sampling. Our specialized drilling system is engineered for reliable soil acquisition, capable of extracting samples from depths of up to 30 centimeters. The unit is a field-proven design optimized for efficient material transfer to the onboard analysis containers integrated with strain gauges, enabling real-time weight verification of samples during transport. This robust mechanical setup allows for precise sampling in diverse terrain conditions, ensuring high-quality data for geological hypothesis verification. Scorpio Infinity can serve as a mobile deployment platform for an integrated drone. The rover's chassis is equipped with a dedicated 50 by 50 cm landing pad mounted at the front, providing a stable base for takeoff and landing. For the exploration subtask within the science mission, we have integrated a Raman spectrometer due to its versatility in detecting minerals in both sedimentary and igneous rocks, as well as organic compounds. This instrument enables us to perform non-destructive in situ verification of our scientific hypotheses, ensuring efficient data gathering without compromising the integrity of the collected samples. At Project Scorpio, we are a team dedicated to developing Scorpio Infinity and preparing it for participation in the European Rover Challenge, where we aim to test and validate our engineering solutions in a demanding international environment. The European Rover Challenge is an important milestone for our team, driving continuous improvement across all areas of the project. Through close collaboration and interdisciplinary work, we ensure every subsystem of our rover works together as one cohesive, mission-driven platform.